Good morning. So we're going to start with chapter 8. And chapter 8 starts to move into similarity specifically with right triangles. So we've been doing quadrilaterals and similarity with triangles that are not necessarily right triangles, but we're going to move into just right triangles for today. So what do you know about a right triangle? We've already done a lot of stuff with right triangles, so tell me some things that you know about right triangles. Rosie? What equals 90? One of the angles equals 90, right? A right triangle has to have a 90-degree angle. Okay, what else do you know about a right triangle? Gabe? The other two angles have to add up to 90, good. So the other two angles we would say are complementary. What else? Anything else that you know about a right triangle? It has 3 angles, good. Not necessarily. 2 sides are perpendicular. Is that what you mean? 2 sides are perpendicular? Yeah, 2 sides have to be perpendicular. And then if the 2 sides are perpendicular, what's the other side called? The hypotenuse. So the hypotenuse is the longest one. The other 2 are called the legs. Good. We talked about special kinds of right triangles, 30, 60, 90, and 45, 45, 90. Does anybody remember what the relationship is there? Or what's special about those?
45, 90 is SS, then S square root 2.
Yeah, so 2 of the legs have to be the same, so we call them S and S. And then to get the hypotenuse, it's just S times root 2. And then 30, 60, 90 was S, 2S, S root 3. Okay, so keep those in mind because those parent triangles aren't going away. So if you remembered them for your test on chapter 6 but have since forgotten them, don't. They're going to be back on your final. Okay, all right, so what we're going to talk about today then is a special property of similarity in a right triangle, which has to do with the altitude. Does anybody remember what an altitude is? It's okay if you do not. Does anyone remember what an altitude is? It's almost the height. Yeah, sometimes it goes outside because it has to go. So in this instance, CD is an altitude because it goes from a vertex and then it's what to this other side? It's perpendicular to the other side. So what Daisy said is right. Sometimes the altitude is outside of a triangle because, for instance, if you have this triangle and you want to draw an altitude from the top corner, you'd have to go right down here. So this would be outside. So when it's an obtuse triangle, the altitude's outside. Perfect. But in a right triangle like this, the altitude here is going to be inside. And it does something special. What this altitude does is it divides this into 3 similar triangles. What are the 3 triangles? BDC is the biggest, smallest, or medium? BDC is the littlest one. So BDC is this little one right here. So if we went here, here, here. And you know that since this is a right angle, what's this? So that means not only does it divide it into smaller triangles, but they're also all right triangles. So BDC is the smallest. What's the medium one? DCA. And then last? ABC, our original triangle. So if we're talking about them being similar, then if we want to name similar triangles, that means we have to name them in what order? Do they have to go in a specific order? Yes. What order is that? By what angles? Not necessarily the right angle, but if I name the right angle first in the one triangle, what do I have to do in the next one? First, and then first in the third one. So it has to go in whatever the corresponding parts are, they have to go in the same order. So for instance, if we want to say BDC for that little triangle, so if I call it triangle BDC, then in the medium triangle, when did I name the right angle in BDC? First, second, or third? Second. So that means in the medium triangle, when do I have to name the right angle? Second. So what would that be? If I went BDC, what would it be for this medium triangle? CDA. Good. So that would have to be triangle CDA. And then what would be the similar triangle for the biggest one?
CBA? Or no, BCA.
BCA. Perfect. So you know the right angle is going in the middle. How do you know, Charlize, that B went before A?
Because since we're using, I know the triangle was the bottom one. So I used the one on this side.
Because that would kind of be the bottom of it. Okay, the way I think about it is if you started with the shortest leg of the littlest one, then when you're doing the biggest one, you have to start with the shorter leg. So BC would be the shorter leg. Right? So those 3 triangles are similar, which means we can use that information to find missing pieces. Okay? All right, name these three similar triangles. What would be the similar triangles here? PRS is our littlest one, right? So PRS, what would be similar to PRS? Here, Jennifer started with which angle?
The right.
She started with the right angle, so that means in all your triangles, you're going to start with the right angle. So what would be the second one? PST, good. Because again, she went from this right angle to the shortest side, so then we start at this right angle and go to the shortest side. And then the last one in our big triangle would be what? SRT. Daisy, could you have done that differently? If you had done RSP, could that still have worked? Like if I switched these letters, could I still find similar triangles? Yes, but would the letters be, as long as you switch them in the other ones, perfect. So if I made this RSP, wait, what? If I made this RSP, then what would happen to this one? If I go RSP, what would this one be? STP, good. And then this one? RTS, because I'm going this, then this, then this. Okay? So again, you might not have the same answer as your neighbor, but as long as they're in the right order, your answer could be right. All right? It just has to be whatever you choose for your first triangle, you just have to stick with that for all three of them. Let me back up for a second. Does everyone see the three triangles in there? Okay. All right, now, to switch gears for a second, we're going to talk about geometric mean. And what is mean? Kind of. It's like the average, yeah. So the geometric mean of two positive numbers is the square root of their product. So break that down for me. What does that mean? What is a product? When you multiply them? Okay, so when you multiply them times each other, and then the square root means you would do what? That would be squaring it. What's square rooting? Not really dividing it, because it's not dividing by 2, but it's figuring out what multiplies times itself. So remember, the square root symbol looks like this. We use it a lot when we're doing Pythagorean theorem and also the distance formula. All right, so for example, to find the geometric mean of 12 and 3, we're going to take the square root of the product. So what would I do first? 12 times 3, which is, and then I would take the square root of that, which is 6. Okay, so the geometric mean is the square root of the product of two numbers. And mean is average, so geometric mean is like our geometric average of two numbers.
So when you do regular mean, do you add them all up?
Yeah, when you're doing the regular mean, like an arithmetic mean, which is what you've done in the past, and no one ever calls an arithmetic mean because it's just mean, you just add them all up and then divide by however many numbers, exactly. So if I were finding the average test score in this class, once I grade your tests, what would I do? Add them all up and divide by, like, I think there's 19 of you? 19, okay? So that's arithmetic mean. What we're talking about today is geometric mean. So geometric mean, multiply them and square root it. With a geometric mean, you're only ever going to have two numbers. So I'm never going to say, like, find the geometric mean of 12, 3, and 9. You can't do it. You can only find it between two numbers. All right, find the geometric mean of 4 and 9. You want a calculator? Does anybody else need a calculator? Calculator? I was just asking if anyone needed one. Miguel, do you want one? All right, what's the geometric mean of 4 and 9? 6. How? 4 times 9 is 36, and the square root of 36 equals 6. All right, what about 6 and 15? How is it 10?
Isn't it 9.4? 8.
What do you do first?
You multiply.
Multiply what?
15 times 6.
15 times 6? What's 15 times 6? 90. And then take the square root of that, which is 9 point, what? 48. All right, so that's an approximate. So you can leave it as square root of 90 if you want. All right, or if you do your calculator in math print, that classic gives you a decimal. If you do it in math print, it'll do the simplified radical for you. So if you want to do it in simplified radical form, you can. I don't care. Sometimes in your book, it'll say you have to do it in simplified radical. I don't care if you give me a decimal or a simplified radical. They're both the same to me. Okay, what about number 3?
So 12 times the 12 is 144 if you square it.
Okay.
And not, so you have to divide 144 by 9.
Okay. Back up for a second. Why is 3 different than 1 and 2? You're trying to find the other number instead of, it's giving you the geometric mean and you're trying to find the other number. So back up for a second. How do you start the geometric mean problems? What do? Multiply the 2 numbers. In this case, do we know the other number? So what could I call it? X. Okay, so we're doing 9 times x. And then whatever you get there, the square root of that equals what? 12? Okay, so what Jennifer said is now to work backwards here, how do I get rid of a square root symbol? Square it. I want to square both sides. So if I square this side and I square this side, what happens over here? 144, because 12 times 12 is 144. What happens here? That just means the square root, like the house, goes away. So this right here cancels out the house. So all we have left is what? 9 times x, or 9x. All right, so then how would I finish that? Divided by 9. Okay, and x equals what? 16? All right.
Wait, so I kind of don't really see it.
Yeah, so going backwards, when we did the original problem, first we multiplied and then you square rooted, right? So we want to do the opposite of that. So we're going to square it and divide, because the opposite of square rooting is squaring and the opposite of multiplying is dividing. So instead of multiplying the numbers, because that's what we would have to do here, right? 9 times something, and if I take the square root of that, that gives me 12. Well, how do I get rid of this square root? Squaring. And if I square both sides, that gets rid of this. So now all I have left is 9 times x. And if I square this side, then I have 144. So then if I divide by 9, that gets x by itself. So to go back and check, you can say 9 times 16 equals 144, and then square root of that equals 12, which is what your geometric mean was. Okay, so if you think about it like, what did I do originally? First I multiplied, then I square rooted. If I want to do the opposite of that, I've got to square it, then divide. Okay? Okay, so at your boards, do these 5. Okay, so geometric mean, again, to find the geometric mean, if they just give you the 2 numbers, you multiply and then square root. To go the other way around, you would square it and then divide. All right, so the reason that we need to know that is because we can use geometric means to find missing measures of right triangles. So take a look at these corollaries. Remember, does anyone remember what a corollary is? Okay, so basically it's like an offshoot of a theorem. So theorems are the things that we know that we've proved, right? Corollaries are basically just offshoots of those. So they go underneath different... What?
That's what I do.
What do you mean?
I always put whatever.
Oh, yeah, I mean, it kind of is. It's just like something that must be true because of something else. So these corollaries have to do with what we just talked about. So in 8.1.2, it says the length of the altitude to the hypotenuse of a right triangle is the geometric mean of the lengths of the 2 segments of the hypotenuse. That's complicated, so let's break down what that means. Basically, what that means is the length of the altitude, so in this case, h, of a right triangle is the geometric mean of the lengths of the 2 segments of the hypotenuse. So what are the 2 segments of the hypotenuse? X and y. So if I did x times y and took the square root of that, that would give me this h right here. Okay, so x, y would give me h. So for instance, if I know that this is 6 and this is 12, then I know that this right here, h, is the geometric mean of those two numbers. All right, so how would I do that? I would do 6 times 12 and then take the geometric mean. So what do I do first with these two? Multiply them and then square root it, right? So square root. So h would be the square root of 72, which is approximately 8 point something.
But we can keep it as 72, right?
Yes. You can leave it as 72, square root of 72. Okay, the other corollary is that the length of a leg of a right triangle is the geometric mean of the lengths of the hypotenuse and the segment of the hypotenuse adjacent to that leg. So let's break that down a little bit, because there's a lot of vocab in there. So the length of a leg, in this case, give me one of the lengths of the legs here. A, so let's say A. A is the geometric mean of the lengths of the hypotenuse. So what's the length of the hypotenuse? C. And the segment of the hypotenuse adjacent to A. So what segment of the hypotenuse is adjacent to A? X, because X is right next to A. So we would say A is equal to the geometric mean of X and C. B would be equal to the geometric mean of what? Y and C. Why is it Y, Daisy? Because that's the one that's next to that one. Okay, so if I have this triangle, no, I don't remember this. Let's call this one A and this one B. And I know that this is 5 and this is 8. How could I find A? Good. Where did Jennifer get the 13 from? Added them together because it's the length of this one times the length of the whole thing. But B would be equal to the square root of what? 8 times 13. Because 8 is the one that's next to B. All right, so if you're looking for the legs, A is equal to this one times the whole thing, square root of that, so the geometric mean of those two, whereas B is equal to the geometric mean of this one and the whole thing. You would multiply them and then square root them, because geometric mean. You add them up there to get the hypotenuse. Yeah. Like, because here they told you it was C, but here we don't know. We know that it's 5 and 8, so we can figure out what that would be. Okay, so in this one, X, Y, and Z, I'm looking for X, Y, and Z. So before I start, I want to identify in my big right triangle, what are the legs? No. 12 is the hypotenuse. 12 will be the hypotenuse. What are the legs? Y is one of them. And Z. Y and Z. Because X is the altitude. Okay, so to figure out Z, what would we do? Z would be equal to the square root of what? 2 times 12. And Y would be equal to the square root of 10 times 12. Okay, do that for me. Find Z. Square root of 24. Okay, which if you simplified that would be 2 root 6. All right, and then this would be equal to what? 120. Okay, how do we find X then? Go back to our corollaries. The altitude is equal to the geometric mean of X and Y, when X and Y are the what? Pieces of the hypotenuse. So then x would be equal to the square root of what? 2 times 10. Good. Which would be the square root of 20. You can leave it like this. You can do it in a decimal. You can do it as a simplified radical, whatever you want to do. All right? So again, the relationship between the legs, z is the relationship between 2 and 12. Y is the relationship between 10 and 12. And x is the relationship between 2 and 10. Okay, go do these 6.